what is going on. So I'm going to try this problem by using a bidirectional approach. So here's what that means. That means that, oops, that's the answer. I mean, the answer goes over a different way to do it. I'm going to do different than that. Yeah, I mean, for the answer, they basically, go and they go like, they go one way and then they go the other way. So let's do this. So we start with this example, right? Now, what we know is that if we start with an array that's 1, 1, 1, we know that we want to basically multiply this times 2, this times 4, right? Because we want to multiply, so in a sense, what I have here is I have 2 pointers that started here and here. So I had 2 pointers that started here and here. And then basically I moved those pointers to here and here. Whoa, I always forget about that. Here and here. So one is my left and one is my right. And when I do that, I keep updating the value. So like my left is equal to 2, my right pointer is equal to 4. It keeps accumulating. But it starts out as 1. And the reason we start out as 1 is because we do not want to multiply the first number by its value itself. So we just multiply it by 1, then we take its value and save it to the left, and we save the 4 to the right. So then we add it to the next number. And then it just keeps accumulating. So now the left will be equal to 14, and the right will be equal to 12. And we will we'll move the pointers to here and multiply these. So 24, 56, 1, and the pointers look like they're in the same situation, but they are not, because what happened is they swap. So like the left one's on the left, now the right one, but now they pass each other by. And this one's going to keep going. It's going to go over here. This one's going to go over here, and it's going to take the cumulative multiplication. So it's going to take the 14 times, for the left, it's going to take the 2 times the 7 times the 3 and add it over here. And for the right, it's going to take the 4 times the 3 times the 7 and multiply the 1 by it. So to do that, you can use this trick with the tilde. So check this out. So if you do for I in range of 10 and you put tilde I, you get -1, -2, -3, -4, right? And if you do negative in something, it will give you the value working backwards. Like -1 is the last digit, -3 would be the third digit from the end. So if we're going to iterate from I equals 0 to 4, sorry, I equals 0 to 3, if we take the tilde of that, we can iterate from I equals -1 to -2 to -3 to -4, which is what we'd want to do here, because we want to iterate from here all the way to that way. So our right pointer, which is moving to the left, we're going to use the tilde for it. I don't know why I'm calling it tilde, but it's the bitwise operator. Unary, it's a bitwise unary operator. The invert operator, that's what it's called. It's called the invert operator. So also, it's equal to this. So if you do tilde x, that's equal to minus x minus 1. So how we'll do this is we'll say res, I'm going to do that. If length array equals to 1. I just have to do this base case because for some reason you're supposed to return an empty list. It kind of makes sense if the array's length is 1. But otherwise we're going to do res equals 1 times length array left and right should be equal to 1 and 1. Range of length of array. We're going to update our res at I by the left, so the left is going to affect the I moving in to the right direction, and the one moving the opposite direction is going to be using the tilde I. So it's starting from the end of the list, and we're multiplying that by the right one. Now we multiply by 1. We want to multiply the first one by 1, but now we want to update our left to be from the array at I, and the right, we want to update it from the end of the array. And these will move in opposite directions, and we're going to return res. So this actually works. It's a very elegant code to get this to solve this problem.